Welcome to A Square Maths by A2 E2. In previous session, we saw one of the application of the Laplace transform, how to solve the integration from 0 to infinity f of t dt by using Laplace transform. Let us continue, and as an exam point of view, let us take some sums of the same type. So here, by using Laplace transform, prove that integration from 0 to infinity e raised to minus root 2t hyperbolic sine of t by t dt is equals to pi by 8. If you see here, sine of t is a trigonometric function. It is divided by t, and whatever the hyperbolic sine of t is multiple of sine of t. So this we don't have direct formula, but if you transfer this hyperbolic sine of t into exponential, you can use the first shifting property, and very easily you can get the Laplace transform of that term. So first you are supposed to find the Laplace transform of sine of t, then sine of t by t, then this one exponential. So let f of t is equals to sine of t, and therefore Laplace transform of f of t is equals to Laplace transform of sine of t is equals to 1 upon s square plus 1. Now, but we don't want Laplace transform of, let us extend it to sine of t by t. So that is integration s to infinity 1 upon s square plus 1 ds. Since Laplace transform of f of t by t is integration s to infinity f bar of s ds. Here f bar of s is 1 upon s square plus 1. And this integration is tan inverse of s limits from s to infinity. And that is tan inverse of infinity minus tan inverse of s. And tan inverse of infinity is pi by 2 minus tan inverse of s. As sine of t is e raised to t minus e raised to minus t by 2, let us put this exponential here only, so that one will be the e raised to t minus e raised to minus t by 2 sine of t, and this can be written as 1 upon 2 e raised to t sine of t minus e raised to minus t sine of t. But we have hyperbolic sine of t into sine of t divided by t. Let us take this now entire part. That means this will be divided by t, and we will get this one 1 by 2 Laplace transform of e raised to t sine of t by t minus e raised to minus t sine of t by t. We do have the Laplace transform of sine of t by t. So here only in this formula s will be replaced by s minus 1, and here s will be replaced by s plus 1. So pi by 2 minus tan inverse of s minus 1 plus minus pi by 2 plus tan inverse of s plus 1. But this pi by 2 and this pi by 2 will get cancelled. This will be a 1 by 2 tan inverse of s plus 1 minus tan inverse of s minus 1. And two ways are to solve this one. You can use the formula for tan inverse of x minus tan inverse of y, that is x minus y upon 1 plus x into y, or you can take tan inverse of s plus 1 is equals to alpha and tan inverse of s minus 1 beta. So tan of alpha minus beta is equals to tan of alpha minus tan of beta upon 1 plus tan of alpha into tan of beta. Any formula you can use as per your convenience. So this one will be the, but tan of alpha is this tan inverse of alpha will be a tan of alpha s plus 1, tan inverse alpha tan of beta s minus 1, and after solving this one you will get here 2 upon s square, 2 upon s square. So this one will be the this tan inverse. So alpha minus beta, we don't want this one, we want alpha minus beta, that is tan inverse of s plus 1 minus tan inverse of s minus 1. So if you put, that one will be the tan inverse of 2 by s square, and you will put here that value, that is 1 by 2 tan inverse of s square. That is the by definition of Laplace transform. Integration from 0 to infinity e raised to minus st hyperbolic sine of t into sine of t divided by t dt, that is equals to 1 by 2 tan inverse of 2 upon s square. But we want to find value of this integral for e raised to minus under root of 2t. So let us put s is equals to under root of 2. So this will be a e raised to integration from 0 to infinity e raised to minus 2t. This term will be as it is 1 by 2 tan inverse of 2 upon under root of 2 the square, that is only 2, 2 by 2 is 1. So 1 by 2 tan inverse of 1, but tan inverse of 1 is pi by 4. So the hence you got the required answer, that is the value of the integral where s is equals to under root of 2 is pi by 8. Next sum, it is similar to that one only, little bit changes here only. Sine of u, this one, by using Laplace transform evaluate integration e raised to minus 2t. Here we are supposed to take, if you apply the Laplace transform definition, e raised to minus st. After finding the Laplace transform of this term, if you want to find this integral, you are supposed to put s is equals to 2 in the definition of Laplace transform. So it is clear that since trigonometric is here, first we will find the Laplace transform of trigonometric function. That is, let us take f of u is equals to sine of u. Therefore Laplace transform of f of u is equals to Laplace transform of sine of u is equals to 1 upon s square plus 1. Now we want to find the Laplace transform of sine of u upon u. So this one will be f of u upon u, and that is s to infinity 1 upon s square plus 1, and value of this integral is tan inverse of s to infinity. Putting upper limit, tan inverse of infinity minus tan inverse of s is equals to pi by 2, because tan inverse of infinity is pi by 2, minus tan inverse of s as it is, and you know very well pi by 2 tan inverse of x is equals to cot inverse of x. So instead of x, here is s, that is cot inverse of s. Now exponential function is there. Applying exponential function, that is for shifting property, here is a is equals to 1. Therefore Laplace transform of e raised to minus u sine of u upon u, that is this part, Laplace transform of this entire part will be a cot inverse of s plus 1. Listen carefully. First we found the Laplace transform of sine function, then divide by u, then exponential, that is for shifting property, and now we will apply the formula for Laplace transform of integration from 0 to t f of u du, and that is only you are supposed to prefix 1 by s cot inverse s plus 1. But what is this? By definition of Laplace transform, this one is nothing but the integration from 0 to infinity e raised to minus st, 0 to t e raised to minus u sin of u upon u du dt, and it is nothing but 1 upon s cot inverse s plus 1, and replacing this s by 2 because we want the value of this integral where s is equals to 2, and that one will be the 1 by 2 cot inverse of 2 plus 1, that is 3, that is 1 by 2 cot inverse of 3. It is the required answer. Next sum. This is special function, Bessel function. It is called as the Bessel function of zeroth order. If Laplace transform of Bessel function, that is j0 of t is equals to 1 upon under root of s square plus 1. Prove that integration from 0 to infinity t e raised to minus 3t j0 4t dt is equals to 3 by 1 by 122. So to prove it, let us start what we have given. Laplace transform of j0 of t is equals to 1 by under root of s square plus 1. But what we want to find? This one, j0 of 4t. So Laplace transform of j0 of 4t by change of scale property 1 upon a under root of s upon a, and as it is. So 1 upon a, what is a here? 4. So 1 upon a, 1 upon under root of s plus 4 the whole square plus 1. Taking 4 square common, and if you cancel this under root, this will be a s square plus 16 divided by 16, and this 16 will get cancelled with this, and that will be because under root of 16 will be there. So, and that will be only 1 upon under root of s square plus 16. After this, you will apply this t. To apply this t, you will use the formula Laplace transform of t f of t is equals to minus 1 d by ds f bar of s. Here f bar of s is this one, 1 upon under root of s square plus 16 minus 1 d by ds, since we are supposed to differentiate it, so s square plus 16 raised to 1 by 2, and this can be written as minus this one d by ds s square plus 16 raised to minus 1 by 2, and its derivative is minus 1 by 2 s square plus 16 raised to minus 1 by 2 minus 1 is minus 3 by 2, and by chain rule derivative of s square plus 16 is 2s, and if you simplify it, this 2 will get cancelled with this 2, this minus sign and minus sign will become plus, this s will be to the numerator, and since the power of s square plus 16 is minus, so it has to be near denominator, or you can write it like this, 1 upon s square plus 16 raised to 3 by 2. Okay, so this one is the Laplace transform of t j0 4t. Next one, by definition of Laplace transform, this part will be the Laplace integration from 0 to infinity e raised to minus st t j0 4t dt s upon s square plus 16 3 by 2. RHS will be as it is, and in LHS Laplace transform of t j0 of 4t, here we use the definition of Laplace transform. But what we want? We want e raised to minus 3t. So e raised to minus 3t, that is you are supposed to replace s by 3. That will be a 3 This will be a 3 square plus 16 raised to 3 by 2, and if you found this one, this will be a 3 by 125, hence the required answer. Thank you. If you like this, share this and subscribe this. Thank you. In next session, let us take some more sums on the basic definition of Laplace transforms.